Alright, so finding the prime factorization of a number. I talked about this a little bit already, but we'll do some more exercise here because we need to be able to find the prime factorization fairly easily in order to be able to add and subtract fractions. To find the prime factorization of 15, what I'm going to do is I'm going to look through my list of prime numbers. 11, 13, that's generally high enough, so that's what I'm going to look through. I'm going to look through and say, okay, is 15 divisible by 2? Nope, it's not even. Is 15 divisible by 3? Yeah, it is. Specifically, this is 3 times 5. So 15 is equal to 3 times, well, whatever's left here needs to be 5. 5 is actually on my list of prime numbers, so that's actually a pretty easy example. It's just 3 times 5, and that is the prime factorization. When we say prime factorization, we're talking about writing a number as a product of a bunch of prime numbers. So that's why I'm starting with my prime number list. So 2, 3, 5, 7, 11, 13. Again, that list can go on, but this is generally enough. All right, so 42. I'm going to start looking through my prime number list, starting with the small ones, because they're, you might as well start small. Is it divisible by 2? Well, it's an even number, so yes. Specifically, it's 2 times 21, so whatever comes in here needs to be equal to 21. All right, is 21 even? No, it's not, so that means there are no more factors of 2. I got one factor of 2 out, that's all I can get, so I'll move on to the next number. 3. I'll look to see if 3 is a factor of 21. And yes, it is. It's 3 times 7. 7 is actually a prime number, so this is my prime factorization of 42. 2 times 3 times 7. Now I'm doing this 21 down here just to show you what all this stuff should be equal to. But really it's 2 times 3 times 7. That's the prime factorization. All right. Let's do 100. 2, 3, 5, 7, 11, 13. Okay. Starting off with 2. Okay, well, 100 equals, 2 times 50. Yep. Let's see, 50 is still even, so that's 2 times 25. 25 is not even, so, there's no more 2's. 25 is not divisible by 3. Or 3 is not a factor of 25, however you want to say that. But 5 times 5 is equal to 25. So I'll go ahead and write that. So my prime factorization here is 2 times 2 times 5 times 5. The prime factorization of 26, 2, 3, 5, 7, 11, 13. I'll start off with my 2. This is 2 times 28. Oops. Let's do it the same way I've been doing these other ones. 28 should be down here. 28 is now the thing I'm factoring. It's still even, so I'll take another 2 out. This is 2 times 14. 14 should go there. 14 is still even, so I'll take out yet another 2. We got a 7. 7 is already on my prime number list, so 56 is equal to 2 times 2 times 2 times 7. You'd be surprised by how many numbers end up, how many of these end up being even. Of course, not everything is going to be even. I don't know why all of my examples are. I'm going to choose something else. Let's do 99 instead of 98. 2, 3, 5, 7, 11, 13. Okay. So it's not even, so 2 is not a factor. 3, let's see, 9 plus 9 is 18. That's divisible by 3, so 3 is a factor. Specifically, it's 3 times 33. 33 is now the thing I'm factoring. So 33 is definitely divisible by 3. It's 3 times 11. And 11 is on my prime number list, so there you go. It's 3 times 3 times 11. Alright, we'll do one more of these. Let's find the prime factorization of 97. Again, 2, 3, 5, 7, 11, 13. It's not even, so 2 is not a factor. Let's see, 3. 9 plus 7 is 16. That's not divisible by 3, so 3 is not a factor. It doesn't end in a 0 or a 5, so 5 is not a factor. 7, well, I don't know about 7, so let's just ask the calculator. Let's go over here and take 97 divided by 7. Nope, 7 is not a factor. Okay, 11. 97 divided by 11. Nope. How about 97 divided by 13? Nope. So actually, I've exhausted my list here. The question is, how far do I actually need to go? I could actually have continued my list. The next few prime numbers, there's 13, 17, 19, 23, 29. I'm just looking at these online. 31. I could continue testing these prime numbers, but actually I have gone far enough. Let me show you how I know that I've gone far enough. I'm going to use something called a square root. So the square root of 97, let's see, how do I do this? Square root of 97 is 9.8. So that means I actually only needed to go up to a 7. If I tested the 2, the 3, the 5, and the 7, 11 is bigger than 9.8. And since I haven't encountered any number that is prime so far, I would actually be done there. I would be able to conclude that this is prime. So the prime factorization of 97 is just 97. Let's try 617. This is a fairly large number, but I'm going to do the same sort of process. But to figure out where I can stop, I'm going to first figure out what is the square root of... Oops. Square root of 617 is 24.8. So the second my numbers start getting bigger than 24.8, I can, I would conclude that I don't need to go any further. So 617, let me just do this like this so I can see that. 617, well, it's clearly not divisible by 2. Divide by 3 doesn't work. Divide by 5 doesn't work. Divided by 7 doesn't work. Divided by 11 doesn't work. 13 doesn't work. 17 doesn't work. And what was the square root? Square root of 617 was 24 point... Okay, so I do need to check 19. 617 divided by 19. Looks like that doesn't work, and 617 divided by 23 doesn't work. At this point, my next prime number on the list is 29, you can see here. And 29 is bigger than that 24 point something. So this right here is prime. If I was to check this manually, check all the numbers up to 617, that would obviously take quite a while. But I can be quite a bit smarter. I can only check the prime numbers and only check the prime numbers up to the square root. So that's kind of a handy way to really reduce the amount of work you have to do.